Welcome to today's tutorial. And today under physics we'll be discussing energy. And we all know that energy is the capacity to do work, as we can see. And we have majorly two types of energy, which are kinetic energy and potential energy. Firstly, we are going to deal with kinetic energy. Now we know kinetic energy is the energy an object possesses by virtue of its motion. So let's imagine we have a formula for force. A net force moves an object of mass m with a constant acceleration. So from here, if you say work done, the formula for work done is force times distance. Since force here is equal to mass times acceleration, finally work done will be equal to mass times acceleration times distance. Work done is equal to mass times acceleration times distance. Substitution for force in this equation. Also, from the third law of motion, we know that the final velocity square is equal to the initial velocity plus 2AD, where D is the distance. Making AD the subject of formula, I'm having AD is equal to B final square minus B initial square all over 2. I can simplify this to be AD is equal to B final square over 2 minus B initial square all over 2. So this is the formula for it. So let's bring it down to our initial formula, and this work is equal to mass times acceleration times distance. Since this acceleration times distance is equal to this equation here, I'm going to say work done is equal to mass times the final velocity over 2 minus the initial velocity square all over 2. Opening this bracket, I'm having work done is equal to mass final velocity square over 2 minus initial velocity square initial velocity square all over 2. Now this equation here is called the work energy theory. So we are going to use this in solving for kinetic energy, like energy in motion. Now this can also be written as work done is equal to the change in kinetic energy. And we know for kinetic energy to change, it will be final energy, kinetic energy minus initial kinetic energy. Now at this point, since it is changing kinetic energy, if we minus the final energy from the initial energy, if the work done here is positive, we should know that work is done on the system. But if the work done after solving this is negative, you know that work is done by the system. Now we are faced with a question here. It says an object with mass of 20 kg moves with a velocity of 30 meters per second, and an event occurs whereby it transfers 500 joules of energy to another object as work. What is the new velocity of the object? Now from our parameters, we know that the mass is 20 kg. The initial velocity is 30.0 meters per second, and our work is 500 joules. So let's solve this. We know that work is equal to 1 over 2 m the final velocity square minus 1 over 2 mass times the initial velocity square. 1/2 is 0.5, and just explain that. So work done is equal to 0.5 into, since our mass given is 20 kilogram, this times final velocity square minus 0.5 into 20 kilogram times the initial velocity is 30 meter per second square. So the work done, remember we are looking for the final velocity. What is the new velocity? That is the final velocity. So this here will be 10 kg into final velocity square minus, since this will give us 10 kg, we can just express this in brackets of 30 meter per second square. So now our work given is what? 500 joules. So I'm having 500 joules is equals to 10 kg into final velocity square minus 30 square will give us 900 meter square per second square. So to eliminate this, we divide both sides by 10. Dividing both sides by 10, I'm having 500 over 10, which will be 50 is equals to final velocity square minus 900 meter square per second square. So finally, our final velocity square will be what? Taking this over here, I'm having 50 plus 900 meter square per second square. Our final velocity square will be equal to 950 meter square per second square. So to find the final velocity, we remove this square by squaring both sides. So while squaring both sides, I'm having the final velocity to be the square root of 950, which is equals to 30.8 meter per second. So this is how you apply the law of conservation of energy in solving a problem. So thanks for watching to this tutorial. Don't forget to like and subscribe.